Hello everyone. Good evening, good morning, or good afternoon, wherever you are connecting in from. My name is Ransi and I am the co-organizer of the AWS User Group Bangalore and your host for this session. So welcome you once again for today's virtual meetup. And this time we have Amit Shah, developer advocate of AWS, here to talk about demystifying the AWS identity and custom application. So Amit has about 18 plus years of industry experience, and in his current role, Amit focuses on architecting on AWS, optimizing AWS environments, and helping customers and partners with cloud adoption with a special focus on Microsoft and .NET workloads. Prior to AWS, he served numerous roles at Microsoft for 11 plus years, helping large enterprises with cloud software architecture and development consulting. All right. So without further ado, over to you, Amit, and take it away.
Thank you. Thanks, Ransi. So the topic of the day today is demystifying identity. And demystifying word has a lot of different connotations. The primary goal for me in this session is we will have a good, healthy identity discussion, right from basics to advanced enterprise customer use cases, and touch upon the services on AWS that will help you take this identity journey. And thank you for that wonderful introduction, Runsi. So here is the quick agenda that I have put in. We'll start with what are the key trends that we are looking. I work out of New York, New Jersey, Connecticut region, so pretty much a lot of financial services. So I may bring in those use cases. Touch upon the basics of identity. Go into sometimes whenever we start discussing identity, there is good amount of Federation, Saml, OAuth, OpenID Connect. So I'll try to demystify or put a clarity around those, and then get into the services that will be useful as you take your journey. But you know what? First, something cool. I usually like to discuss like what I saw in last few weeks. I have two daughters. One is 10-year-old and another is 5. And I came across this power-up toys. And it's pretty neat. Smartphone controlled paper airplane. I'm excited. It's on the way. It's coming to me. This is really, really cool. The second one, which I'm super excited, is Honeycomb Service. And if you are not familiar, it's recently launched a service where you can pretty quickly create applications for like simple to do custom tracker, content, time of reporting. So if I want to do it, let's say I want to do a simple to do application, right? I can very quickly create a model. And from that model, I can quickly create applications. And that application is not just web. It also gives you iOS as well as Android based use cases. So pretty quick, like within minutes, you are able to get your application created, running, shared, SSO with search, CRUD based operations. So that was also something which I found pretty cool. Cool. So let's go back to the topic of the day. As I said, I work a lot with FinServes. So in FinServes, if I take 4 years back and today, there is significant changes. 4 years back, I was discussing PII, HBI, regulatory rules. Now it's like, Amit, we want to move this. Help me migrate. How can we modernize this? So different kinds of workload. Previously, it was just dev, test, infrastructure-oriented workload. Now it's all over the place. They probably start with digital banking, the actual websites content, and then they move into the meaty processing, quantitative analysis, risk calculation, and others. So that adoption has significantly gone, and with that comes complex use cases, right? So what I want to say is when an enterprise customer starts on AWS or on any cloud, they initially look to identity as a very big, undifferentiated, heavy lifting work. The goal in the cloud is to actually modernize the identity also, right? Move towards more token-based, more self-service based operations. When an enterprise customer starts, they usually start with something called AWS account, right? We start AWS account, you may soon have multiple set of AWS account. To manage that, we have the service called Control Tower. And Control Tower is ability to give you that landing zone, the multi-account VPC setup with guardrails and centralized identity access. So as part of my work with different enterprise customers, what are the key characteristics that I have seen in modernization and migrations, the large scale ones that are there? So I'll put very quick 4 things. Automation, importance to automation, giving the importance to automation at each layer, DevSecOps, infrastructure provisioning, security rules, governance, compliance. Each layer, the more you automate, the faster you're able to move. Second is the developer first workflow. When I say developer first workflow, if you create account VPC and just don't think from a developer point of view, the developers sometimes struggle to connect work with the infrastructure services. I'll give you an example. One of the enterprise customer infrastructure engineering team, they actually created a portal where all they want the developer team to give them is the GitHub location for their application. And they abstracted the type of hosting, be it EC2 or container or serverless, and that was a choice, and it took care of the CI/CD flow. I mean, I'm not saying everyone has to go to that abstraction level, but thinking developer experience is super important to get that nimbleness and ability to move fast. Third is the data strategy. Pre-cloud data was kind of with the applications, and there was not importance to data strategy. Now I see significant amount of enterprises actually creating data services and sometimes looking to ways to monetize on top of that data services. Decoupled product. This is, you probably have heard the term monolithic microservices, have a modern application, smaller components, Lego blocks. The idea is architecture, you don't want to couple things, right? You want to have different blocks which can move on its own. So microservices based architecture. Now, how do I map these all terms to identity? If you see, modernization area, when I said automation has a script, it runs under a context of an identity. Somebody deploys that script. Again, builder identity. Application architecture, if you build so many microservices, you have to do authentication authorization across those microservices. Identity. CI/CD, DevSecOps, who actually, once the developer has checked in the code, who promotes that? Who does code review? There are different levels of authorization access. Data lake, you may actually want to create your own data lake and then from there make another set of use cases for upstream and downstream dependent systems. Again, role driven, attribute based, because not all data has to be accessible by everyone, especially in Fencer where there is strict security around who can access what, right? So each of this area has an identity connotations. So unless you look identity and give it as a real importance right at the start, you may actually have good amount of rework later, or you'll be lucky if you don't. So very quickly, coming to the identity landscape, I just wanted to take a because I've been told there are different levels of people here, some with very good experience on AWS and identity, some with just getting their hands dirty, and some they're looking to foray into the cloud and the identity world. So very quickly, what do you hear whenever somebody says identity? A user has an attribute, first name, last name, email. Sometimes you will hear group. Just from a management convenience, you can put set of users into a group and then actually manage them together. Identity store, right? Active Directory, others are pretty much well known. So you need some kind of identity store. And usually there is a flow for identity, right? If you take from a corporate employee point of view, a new employee joins an organization, an employee changes roles, an employee leaves, each one is a flow for identity. New employee joins, a new identity. Role change, permissions different. Leaving, that identity has to go away, and anything other that was dependent, that access should go away, right? So an identity is human as well as machine. In AWS, EC2 can actually assume a role and do some operations. Lambda can assume a role and do some operations. So machine is also another use case. So I'd like to just quickly bucket them into corporate and consumers. Corporate, pretty well-known example is Active Directory, which has the actual repository of all the users. On the right-hand side is the consumer, where the Facebooks or the Google or the Twitter or the Amazons of the world are there. So consumer identity comes very useful when you have an application that is being accessed by an end client. So that's the time when you would think in terms of integrating with consumer identities. So authentication, who? Authorization, what? And multi-factor is basically if you have to have additional on top of it. Pretty much, I'm sure you have enabled multi-factor on your AWS. If not, go enable it right now. And you probably are using some kind of authenticator apps across different cloud. It's just another form factor where you get verified that that's check factor from because of security attacks are increased significantly. So identity management, resource management, and access management. They go hand in hand, right? Users, what can they do? What resources can they access? That's very, very important. Now, as you build, we came from the world of username passwords to federation. And federation could mean different thing to different people. So I'll just quickly summarize. Delegating an individual or entity's authentication responsibility to a trusted external party. Delegating authentication responsibility to a trusted authentication responsibility, right? So Active Directory is very, very well known. Now, in the world of SAML, there are four terminologies. Identity provider, again, you can map it to Active Directory. Security assertion markup language. This is SAML is a protocol. It has a specification. And that SAML, once you have authenticated, you get a SAML assertion. And SAML assertion is understood by service provider relying party. They initially have had the setup in terms of metadata exchange so that they know that, hey, this SAML assertion, I can understand it because I know from the metadata exchange, right? What's the typical flow? If you look at the Identity Federation SAML flow, here is on the left-hand side, you see browser interface. There's the Identity Store IDP portal. Here is the AWS sign-in. I'm assuming, let's say that you have a Active Directory based flow. So user logs in to the portal, IDP portal. So let's take an ADFS or a website where you go, you log in, domain, user, password, you get authenticated, right? Once you have been authenticated, you get a SAML assertion. So in the AD world, there is something called Active Directory Federation Services. You use that, it gives you a SAML assertion. And that SAML assertion is passed onto AWS. AWS understands, AWS will have a mapping based on a user. You may do a mapping by a role, like IAM role, or you may do by custom user attributes. That role has policy, and that defines what that user can do on AWS or cannot do. This is an example of SAML assertion. It's pretty kind of bulky, XML based, and I would say that it also needs to evolve with the cloud because everything is getting simplified, and this also needs to be, because if I am already seeing use cases where enterprise customer who needs to pass on a lot of information in SAML assertion are hitting some of those limits. Other than SAML, you will hear the term OpenID Connect and OAuth2. OpenID Connect is an interoperable authentication protocol on top of OAuth2. OAuth2 was built from an authorization framework. Now, to understand where it came, look at the pre-OAuth web history. I can't believe, like, there actually was website which asked for the username and password for that email and to access the contacts, and that happened. I mean, today I don't think that's gonna be possible. We move towards OpenID Connect, where you have the IDP provider, relying party, so service provider, relying party, and what you get is something called token. And there are different types of token, like identity token, refresh token, bearer to access tokens. So those, each token has a different use cases, right? So the idea is OAuth for authorization, primarily used in mobile web-based use cases, API call, REST services, and OpenID Connect was built on top of it for authentication purposes. Here you go. JOT, you probably have heard JSON Web Tokens that gets used. Very quickly, here is a representation of it. It has a header and it has a payload. Different types of token, identity, access, and refresh, right? So that's the actual, so SAML assertion in the world of SAML Federation, right? Here you're seeing the JOT tokens. Another one additional thing you might hear is SCIM. Systems for Cross-Domain Identity Management. It is a protocol built by Oracle, Salesforce, SailPoint, and Nexus Technology. Think of it like if I integrate AWS with Azure AD. Azure AD can be my identity master, and AWS SSO actually has the rights of defining the rules of access and resource definition. So that's another model that you will see. And in the website realm, there is something called JIT provisioning, just-in-time provisioning. Think of it like some websites that give you ability to create a user, register. So JIT can actually update the actual identity store with the new users. Okay, so that's very quick terminologies that you would hear. Now come back to AWS again. Pre-cloud, you have a corporate data center. Primarily in your on-prem, you were doing perimeter-based. So you have firewalls, and based on that, that is where the security is implemented, right? You have a corporate firewall, employees, resources are in hundreds, employee passwords centralized, right? We moved with a lot of disruptors, mobile consumerization of IT, the social identities that came up, and microservices-based architecture. All of these played a role in changing towards zero trust, authentication at each layer, and authenticate everything. So primarily security responsibility is consumed or slowly moving towards the authentication layer. And then there are newer compliance, GDPR, where we have to adhere to those guidelines, right? Decentralized, and hence in the AA cloud world, we move towards pervasive security at each resource. So if an application has EC2, API gateway, DynamoDB, S3, you are actually doing a resource check, authentication check at each of those services. In AWS, there are three things: IAM user, groups, and role. User is permanent credential, group management convenience, put them together, and that's where the IAM user comes in. Role is the most important. Yeah, and role is not permanent credential, right? So it does not have a standard long-term credential. Usually what happens is an IAM user will assume a temp credential, assume a role, and that role actually generates the policy assigned to the role, gives what that person can do. So an IAM user calls, and typical flow that I'm showing you, STS is another service to get temporary credentials, and it's valid for some period of time. The role has policy, and that policy defines what that user can do or cannot do. So think of this: identity, resource, policy. Always you're living in this world from now onwards. How did we come to this stage? We started 2006. There's root user with one account, one user. Move towards IAM users, one account, many users. Saml Federation, because I want to have one identity store, right? So Saml Federation, remember delegation of authentication, that's where it came in. Switch roles, a lot of developers work on many different projects, so they needed the ability to move and switch roles. AWS organization, initially many enterprises started with one account, but slowly they had many different AWS accounts, and suddenly they have business units coming in, different LOBs coming in. So manage that AWS organization as a service. SSO is primarily from a single sign-on, so that you get authenticated once, and then you can single sign-on onto a different set of application, right? So, and 2019, we actually have external directory support, Okta, Azure AD, there are others that are supported, right? Security token service is the web service that you can ask and get a limited time, which is configurable, temp credentials. Let's quickly see a STS example here. So this is basically, I'm giving you in Visual Studio with a tool, AWS toolkit installed. And let's quickly go there and show you a demo here. So I have a toolkit installed. Once you have a toolkit installed, you're able to see all your resources right inside Visual Studio. That's the beauty of the toolkit. This is my sample in which I'm actually going to find out in an S3 bucket how many objects are there, the count of them, but I'm going to first generate a temp credentials using STS service. In this case, I have configured the credentials. There's a profile. I can always go and add new profile, give the IAM details. So here you go. Let's quickly run this. So here's temp credential call, get temporary credential async. I like to debug it and see. Here is the client to STS. And I am asking for duration 7200 seconds. Okay, so that gives me the credentials. I get that credentials back and use that credential for the bucket that has been passed as a config, and get the objects and get the count of it. So in this case, if you see, I use the AWS .NET SDK, and it's pretty straightforward. Like the service that you're using, you see this typical pattern of Amazon.servicename, Amazon.servicename.model. Similarly, Amazon.securityToken, securitytoken.model. All right, and that gives me a response of how many count are there inside that bucket. Right, so very quickly you will have temp credentials based SDK calls. You may have assume role based calls. Assume role is nothing but internally actually gets a temporary credentials that assumes that role, and then you use that temporary credentials to do some operations. Okay, let's go back here and continue. So you have human access, one account, and then suddenly you have so many accounts, right? You will have, but identity actually lives inside an account. So IAM identities lives inside an account, right? That's the key part. Organization, as I said, it evolved AWS org from the need of multi-account governance. So you could do SCP and control what is allowed and not allowed in the child accounts, right? Let's quickly get into the complexity of once you have so many accounts, so many resources, how do you manage? You will hear the word tags, and the better you tag, the better the governance that you could have. So IAM users, typically you start with IAM users. It is a permanent credential. You're not using identity store, right? There is no user directory, no identity store. It's a long-term credential. You might have heard from SAs and AWS TAMs that, hey, rotate your credentials. It's important, right? You do not want something to be compromised. You log in with your account and IAM users. Once you have many accounts, you may do a AWS single sign-on user pool. Again, you're still not connected to your own user directory. So pretty much from a multi-account access model. But then enterprises wants, hey, I don't want to recreate. I don't want to have a separate credentials. Think of it from an employee point of view. He joins, he leaves. If you have IAM user and he leaves and it's not connected with the corp identity, he still has access to AWS environment. So hence the reason to integrate between the two, right? So that's where ADFS comes in with Saml Federation based logic. And as we saw before, the same thing: authenticate with your IDP, Saml assertion. Metadata exchange has happened before, so you do that, you come back, and you get that. Active Directory has different flavors in which you can configure it on AWS. Either you can have your on-prem AD, you can have AD on EC2, or you could use AD as a managed service. And we support each one of those use cases. When do you use it? Like primarily, you will see an EC2 domain joining use cases, LDAP based call, Kerberos delegation. That's one typical flow. Managed services, right? If you are connecting to RDS or FSX for Windows Active Directory, that is very, very useful. Single sign-on, that's also another use case. AWS applications like workspaces, AppStream. Like let's say if you are streaming a thick client-based application and it needs to authenticate, the user needs to be authenticated by Active Directory. That's another typical use case. SSO is another, because you do not want to, because you may want set of applications to be like SSO enabled. So once you are authenticated, you're able to seamlessly move across those applications. So we have our own SSO, and we also support integration with other Okta as well as Azure AD. Right? What is the guidance quickly here? If you have an existing user directory, that's the key part. You will do either SAML Federation, SSO based integrations. If you don't, then you will do IAM users SSO with user pools. So what about non-human, right? That was pretty much from a human point of view. As I said earlier, EC2 instance, Lambda can also assume a role. When you are actually creating IAM roles in your console, you have ability to specify that, hey, this EC2 instance is calling AWS services on your behalf. So an application, if it runs inside EC2 instance, if it does something with S3 or DynamoDB, if you can give the EC2 instance the role, it will be able to do those operations, right? And the role has the policy which gives the permission to manipulate S3, right? That's where we come in with the policies. We have managed, we have enterprises writing their own policies also. Typically, what is a policy? You have a statement, effect, action, resource, right? And action resource is the key part here. In this case, I'm specifying get, list, describe, search. So pretty much read-only based operations I'm allowing. Usually, you will have admin and read-only for sure. You may have many more as you take your journey, right? Let's just quickly see a path. Here is one example of accessing EC2 instance, accessing a DynamoDB ***. Again, if you show it to an InfoSec guy, he'll freak out because ** is wildcard. It is open. Principle of least privilege. You want to give only what it's supposed to do. So you face of judgment, as you can see. So you slowly actually evolve from this policy. Maybe you wrote the specific actions, but resource is still star. So I may want to actually further improve this policy, and hence comes the actual reference policies, and our AWS documentation on IAM helps you define that how you create it. So in this case, I'm specifying a specific resource in this region and this particular table. So that will make InfoSec guy happy, right? So that's how you evolve your IAM policies. And slowly you actually restrict to the principle of least privilege. You may have needs to have cross account based access, and IAM user from one account, IAM role from one account needs to access some resources on the other. So you could set up that trust between the accounts, or you could do it at the level of organization. In this case, it is giving the principal org, right? So you have, whenever you have cross account resource based policy, it is very, very important. Entire account versus AWS org, depending on your InfoSec policies. So you see that there is on the right hand side, what are the three things? AWS, basically accessing console, CLI based call, PowerShell based call. Infrastructure is the actual operating system, databases, right? You may want to install, upgrade, patch, that kind of thing. Applications that you host on those compute, right? Be it containers, EC2 or Lambda. And on the left hand side, you have type of users. There is builders, there's operators, and users. So users are the end users. So users are primarily accessing applications, right? Operators and builders have sometimes the need to actually provision resources and manipulate. So they need access to log in and get if they have to install customs. This is the typical flow. If you have for the AWS console, you will do primarily SAML based or SSO based implementation, right? If you have the operator may need to do operating system, database engine, and kind of infrastructure oriented work, right? And sometimes EC2 instances may need, so IAM role funder. So if you take operator point of view, traditional was domain joining, LDAP, Kerberos. You move towards IAM auth, right? That's the typical. You want to go towards IAM auth, where either it's permanent credential or IAM role has the policy, and based on that, the operator can do those operations. Again, principle of least privilege. For a period of time, the token is valid for that amount of time in which that operation can be done. Utopia, NoOps, I mean, in the DevSecOps worlds, the idea is to get away from undifferentiated heavy lifting. I mean, yes, I have not yet seen an enterprise customer who doesn't have, who has completely gotten rid of operations. There is still some or the other element of operations, because there are many times legacy applications, and changing the architecture of those legacy applications is pretty hard. So they are lift and shift, move and tune, what we call, and they're running an EC2. And once you have it on EC2, you have the good amount of operational work, right? Typically, the flow, if your code is accessing, in both the cases, you are having temporary security credentials. It assumes a role has policy, and based on that, it gets access to what it can do or cannot do, right? There is another flow when sometimes you want like database connection string, some other secrets, or application has configurations, and those configuration values to be stored somewhere. So AWS Secrets Manager comes very handy, and you could actually access them and use those to connect. That's another authorized flow using the secrets manager. Parameter store is another service that's used for some of the configuration management. So how do I go from human to application? Now this is the application flow, where a user who is accessing an application that is deployed on AWS, right? So let's quickly see. For human to application, you have something called Amazon Cognito. And Cognito has a typical user pool or identity pool, and you could do social federation as well as SAML-based federation. So Cognito is a service that helps you get rid of undifferentiated heavy lifting for identity. So that's the typical path, right? So it has its own cup token. Remember the chart I showed you representation, and there are different levels of it. If that you need a Cognito flow to access AWS resources, you may do identity pool, temp credentials, and temp credentials can access. They have roles that can access the other AWS resources, right? Typically, what is the flow in Cognito? Is you create a user pool. You specify the details of that. That is important because that you will use in your application. And once you have specified the client, you have specified the app client IDs, you integrate. In this case, I'm using a configuration file in ASP.NET application, and that specifies Cognito client ID, metadata address, so sign out URL, where to go back, that kind of thing. And it has the ability to give you the authentication, sign up, registration, uh, all different use cases. It has hosted UI. You can customize that branding point of view. Supports OAuth 2. The actual Cognito user pool has support for OAuth flows. Right, Cognito identity can go in different realms, right? Business to consumer, business to business. Let's quickly see, like, when do you use which one. That's the important part, right? I mean, this is all typical flows of what all feature does it provide. It has profile data, typically what you will expect. Sign up, right? Registration, forgot password, token based, email verification, SMS, multi-factor authentication. Right, you could do custom attributes if you have the need for it. It has different SDKs, right? If you want to build a native mobile application, you can integrate with AWS Amplify. It's a different set of backend. How do you integrate is the key part. Different applications, when you're going towards microservices, you may do a API gateway based flow or ALB based flow. Let's quickly see how you actually implement the API gateway, different types of authorizer. So first is Cognito authorizers. So here you go. I am actually authenticating with Cognito user pools. I get the JOT tokens. I call API gateway. API gateway validates the access, calls the Lambda function, and Lambda function accesses the resources. That's one path of it. If you want IAM authorization, so JOT tokens, and now you need to interact with identity pool to get temp credentials. So authenticate, you go back and get the JOT tokens, go to the Cognito identity pool, validate it. You have the temp credentials. You pass in that via HTTP, and API gateway now checks IAM policy, what access level it has, and based on that, it allows or not allows. Other is Lambda Authorizer, right? Lambda Authorizers. Basically, if you're integrating with the OpenID other social system, you authenticate, you get back the cup tokens, call the API gateway. Now here, API gateway outsources the authorization work to Lambda. So that's the Lambda function, does the authorization, validates it. And then if depending on whether you have to have an identity interaction, you go IAM, policy verification, and you come back and authenticate it. Right? This is a typical pattern you will see in service to service based flow also. Right? You can do a pitch HTTP based call, and if I have a very sample quick on the service call, here is you go, temp credentials, here you go, HTTP call, and if you closely see, here is the authorization, right? And it's passing it via the SIG4, right? So that's the HMAC signature. So that's how you pass on between microservices if it is over HTTP, right? This is now tokens are different, and bearer token versus refresh token versus ID token. You may want to go and understand. The OAuth 2 specification was primarily from an authorizer. So when I say authorizer, remember pre-OAuth, you went to Gmail and you got your contact list. Now you actually specify, you go to, let's say, Gmail, or you go to LinkedIn or Twitter. The Twitter will prompt you that, hey, this service provider, Lang Party, is trying to access these attributes. Do you allow or do you deny? So that information actually specifies that, hey, these are the attributes that has been allowed to access in the access token, right? Refresh, because the token, the ID token that gets generated is valid for some period of time. Ability to refresh it is where you need the refresh token. Okay, so those are different use cases that you have to do. Now coming to attribute-based access control, where enterprises, I'll give you example. In financial services, sometimes you have wealth management, investment banks, right? There is a clear delineation between one business unit and other business unit. So you have to have a right level of permissioning. So what you do is you pass on additional attributes. Let's take an example of Active Directory itself. Which org or business unit employee belongs to, you can pass that attribute in the actual Saml assertion, right? And that attribute is available with the session tags. You could actually probe and find out what information is there in the session tags and do a custom dynamic policies, right? What is the group that he belongs to or business unit that he belongs to? So it allows you to write dynamic policies, and based on the variability of that information that came via the SAML assertion, you will be able to do those complex authorization flows, right? But still, sometimes what happens is that SAML assertion has a limit of number of characters. So some customers say that, hey, I could pass on as a, if you see the attributes in the assertion, I can, and remember SAML assertion is XML. So if it is an XML based assertion, it has a size limit. And sometimes some enterprise customers or financial services customers have a huge, like millions of attributes. And it's very, very hard to get those level of information serialized and passed over a SAML assertion, right? And that's where one thing that you will see is something called custom broker. A custom broker, some enterprise customers go for, either from a let's say multi-cloud abstraction point of view, like, hey, I will have my broker on-prem, it will go across different cloud. Again, there is pros and cons of it, but it is more complex than actually implementation wise. Second is custom broker from an authorization point of view. Like if the enterprise has actually invested significantly in building their own authorization layer, right, and they have built over a period of time, it is very hard to replicate that into IAM policy because it takes time to actually write those. So sometimes having a custom broker on AWS to allow those custom authorization flow is an easier solution to start with. I mean, slowly you may want to move towards more cloud native solution, but that is one flow that I have seen some customers do on the custom authorization. Here is a quick blog on end-to-end session tag implementation. And like I was telling you, the department value to Amber, department value to red, and you could use those department value once that has been passed in your session, and configure policies which probes and actually does some maybe allow or deny based on what that attribute value is. So that's pretty useful, but again, it has a limited set, but I think 5,000 characters or something. Don't quote me on that. And you can pass those, write variable policies, and allow those custom authorization based flows. Okay, so that's the custom authorizer. Fine-grained permissioning is one more topic that comes in data lake oriented use cases. I'll give you a history of this one. A lot of customers are building data lake on AWS, right? I mean, it starts with S3. You dump all the data on S3, and then from S3, you're actually moving data to different use cases, maybe Redshift. Maybe you want to take it towards Athena. Maybe you want to do an EMR-based processing. Maybe you are taking it further, doing some kind of ETL on top of it. So the data moves at different services, but data has permissions, right? Permissions don't move along with that. And that's where the lake formation service came in. If you see the AWS lake formation service implementation, it has a security broker built in. So it gives you the ability to define who has access to what, and that is used whenever somebody accesses the same table in Redshift and goes further. So your data moves, but along with that, all the services that adhere to AWS lake formation actually support that fine-grained permissioning needs also. So that's one example of fine-grained permissioning and implementation, primarily in the data lake, but it could very well be in other use cases also. These two are very, very important development. The session tags for custom policies, which are dynamic in nature, and then lake formation-based you have the data lake where not just data, it's also the permission of that data that goes further, right? We have another service that was launched. Actually, now it's not new. It was last reInvent from an access analyzer, because you have so many IAM things happening, right? all the API calls, be it from a CLI, PowerShell, SDK, console, you are doing so many IAM access. You're doing temp credentials. Who is accessing what? So Access Analyzer is pretty neat to understand who, let's say, an S3 bucket, who accessed it, which account was it. So that is a pretty neat to know. You can say CloudTrail for IAM kind of thing, right? So that's very, very useful. By the way, we have AWS security and certification training, and that goes across all the other security services. If you are interested, you probably want to look at the security specialty certification. Now, so I'll try to come back to the summary of it. There is a basics of users, passwords, MFA, and then there is SAML, OAuth, OpenID Connect. There is corporate use case. There is the consumer use case. You have a typical SAML-based federation setup in AWS, and anyone that adheres to SAML 2.0, we can integrate metadata exchange and good to go. Pass on, and with session tags now you are able to pass some custom attributes also. For the applications, end user who is accessing that, Cognito is available. You could start with pretty much a SCIM provides the ability to create a new identity on the fly. So a registration flow. Hey, I'm new user, register, and that could be a SCIM API call to update the identity store. And Cognito has built in both user pool, identity pool. User pool, it has its own. It adheres to OAuth 2, so you could do access token based manipulations. And if you need to access AWS resources for which you need a temp credential, you use identity pool that gives you the temporary credential, assumes the role, which has the policy, and then you access the corresponding resource. These are the typical path of flows. Where I think we will move towards simplification of IAM policies, right? Because all said and done, it is still sometimes complex to understand all the different action resources and getting that right. So we are working towards more simplification on the IAM policies. Okay, and with everything, it's a journey. It is not like one and design and done. Just like if you take pre-cloud era, an application architecture once designed in a Visio or somewhere, that was it. Right now, it's basically evolving every day. A new service got launched. Maybe I don't want to. Like typically, an application when you bring onto AWS, you may start with lift and shift to put it onto EC2, but soon you realize that no, I want to run in containers. I don't want to do EC2. I want to do Fargate, maybe serverless containers. I don't want to do this. Why am I paying when I don't have a request? Maybe I want to go completely either towards serverless containers or API gateway Lambda based use case, right? So that's the general trend. OAuth based web applications, mobile applications. A lot of startups are building identity around the same. SAML has both advantages, and with very complex use cases, SAML also is hitting limit. So probably the identity consortium may evolve further with those specifications. The open identity team. With that, I hope I am on time. That was a very quick run through of identity. I don't know if I demystified or I did a more mystifying. Hope you got a pretty journey of identity basics to the options on AWS, and look forward to having more conversations on this. And I'll open up for questions.
Sure, yeah. Thank you, Amit. That was like a very insightful session on the AWS side. You've touched upon almost everything that the AWS had to offer in terms of demystifying the authentication author. It surely was demystified for me. So I personally enjoyed it. So yeah, we have one question on the live stream, and that is like, how do you monitor inactive users in AWS from a billing perspective?
How do you monitor inactive users in AWS and from billing perspective? I have this service. I don't know if you have explored it. Config and config rules. So AWS config is basically every resource in AWS. When it changes its state, there is a representation of configuration item for that resource, and it also includes IAM entities also. You could actually write config rules for the same, and it could very well a lot of use cases. I'll give you examples of customers that I have done. You could do proactive also, by the way. Like if you do not want your developers to create R4 8x large EC2 instance, you could write a config rule that checks on instance create, right? That is the EC2 instance type allowed or not allowed, and then stops that operation. So proactive governance, if I may say. Similarly, IAM policy changes. You could write a config rule that checks maybe for wildcards, right? I mean, that's another one. Proactive kind of security. So you could do a config rules based implementation to check on those. Hopefully that
Okay.
helps.
Yeah, sure. I believe that's. I believe we do not have any more questions. There's just one request for the slides. So
Sure.
Amit, you would be able to share it me and okay, right?
Yes, definitely. I'll be sharing the PDF version of the slides.
Sure. Yeah. So once I receive it, I should be able to publish it on our SlideShare channel of the AWS User Group Bank. Okay. So I believe that's it. Yeah. It's we do not have any more questions. It's a pleasure having you, Amit. We look forward to hosting you once again. And thank you again. Do you have
Same.
anything
Thank
to
you.
say
Thanks for
for?
the opportunity, Runsi. This was really a good start. I mean, and as folks give you feedback, and if there are specific use cases that they want to go more deep into, maybe just take one use case and do kind of workshop-based demonstrations. I'm happy to take those unique cases and do further sessions on this.
Sure. Yeah. Thank you for that offer. Yeah. We'll definitely pass that feedback to the user group and look for any responses there. Sure. So with that, I believe it's a wrap. And thank you so much again. And request everyone to like stay home, stay safe, and save lives. All right. So with that,
Thank
bye
you.
bye.